Good day, folks. Welcome to Creates Mind Academy, where we bring brilliance to every lesson. So, this is the new video after the previous video where we discussed all the fundamentals of parabola, how it started, and all of that, the shifting and all of that, right? Then, now we have more of the quadratic formula function, okay? Remember the first one that we learned, it was the turning point formula that goes like y is equal to a into x plus p squared plus q. This was the turning point formula, because it can already give you the turning point formula. But I also said there is also what we refer to as the standard form, ax squared plus bx plus c. So in this case, in this video, we're going to be looking more on this standard, okay, how it differs from the turning point form. So now let's read a little bit here. It says quadratic functions are often encountered in the form of y is equal to ax squared plus bx plus c. When a function is given in this form, the shift and hence blah 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 are not immediately clear. Okay, the shift and hence the coordinates of the turning point are not immediately clear. Unlike when we are looking at y is equal to a into x plus minus 4 squared plus 8. This we can see that it's shifted. Remember, I said if your p is negative, it shifts towards the right. Okay? Remember, x minus 4 it is equal to 0, therefore x is equal to 4. It will be moving towards the right. I can see it moved 4 units towards the right, okay, and 8 units up. And also the turning points, it is what? 4 and 8. But now in this standard form, in this form here, I cannot see all those things clearly, okay? So we can easily rewrite this form in y is equal to blah, blah, blah. So we can take this standard form to what? To a turning point form. But how do I do that? I need to know how to complete a square. Remember, you did that in term 1. In term 1, you did how to complete a square in grade 11. And yeah. Now, let's look at this. Determine the turning point of y is equal to x squared minus 4x plus 3. There is an easier way. You'll see where x is equal to negative b divided by 2a as we move. But I want you to learn this in case the examiner says, write this form in turning point form. Okay, write the equation in turning point form. Okay, or complete the square. Okay, so when you complete the square, you're gonna say completing square. Okay, by completing the square, we're going to say y it is equal to, we have y is equal to x squared minus 4x plus 3. When completing the square, what I'm interested in most, it is what? This. And I have to make sure that the value of 8 is 1. Okay, yes, in this case, it is 1. Then I'm interested in this part. Okay, this part is the one that I'm going to be interested in. What do I mean by that? It means I'm going to say y is equal to x squared minus 4x, and then I'm going to leave a space here. Okay, and then plus 3. On that space that I'm going to leave here, I'm going to say this coefficient of x, which is 4, I'm going to divide it by 2 and then square it. Okay, I'm going to say I have minus, what is the coefficient of x? It is 4 divided by 2, and then I need to square it. But can you see I'm introducing a new term? If I'm having x squared minus 4x plus 3, if I say x squared minus 4x plus a divided by b squared, remember, if I want to go back plus 3, if I want to go back to this original one, I need to remove this plus, okay? Then I'm going to minus what? The very same number, so that they will do what? They will cancel off. So this is basically that. So I'm going to need to do what? If this is minus, I need to do what? To add that also. 4 divided by 2. And then I need to do what? To square that. And then I'm going to focus on this one, the first 3. I'm interested in the first what? The first 3 first. Let's simplify that, the first 3 as well as the others. So we're going to have y is equal to, okay, I'm going to take the first 3 as x squared minus 4x minus 4 divided by 2 squared, it is 4. Okay, and then plus the rest. Actually, even if I can use this bracket, what is the rest? It is 4 divided by 2 squared, which is 4. 4 plus 3, it is what? It is 7. Can you see? So far, I'm already there, because remember the form that I wanted is y is equal to a into x plus p squared plus q. Okay, but I already know that the value of a, it is 1 here. Remember, if this is the standard of y is equal to ax squared plus bx plus c, the a is the same. So can you see that a is 1? So I'm expecting here to have something like x plus p squared plus, already I have what? Plus 7. So I'm only left with this, okay? But if I check at this, when I look at this is what? This is the different, no, Maka. This is the same as if I'm having x minus 2, okay, all squared. Now, how do we know that? Okay, before I come to this step, let me show you this one so that you'll always remember. What is it that you're going to put in your bracket? Here, I'm going to have something like y is equal to x squared minus 4x minus 2 squared plus 2 squared plus 3. So remember, now I grouped what? These three. Okay? So normally this is what is going to be inside your bracket when you simplify this any further, okay? So this term here, the 2 here, or this 2, is the one that you need to simplify in terms of, again, so it's going to be x. Then can you see that it's going to be x minus what? Minus what? The value here, which is how much? Which is 2. And then I need to square it plus what? Plus 7. You can confirm this, or is it giving you back that number? Let's see. You square the first term, it is x squared. X multiplied by negative 2 multiplied by 2, it is negative 4x. And then negative 2 squared, it is plus 4. Therefore, it is not the same. Therefore, I need to go back and say, okay, it means here, in completing this, there was something that was a mistake. Which one is that? We say, okay, if this is minus here, it does not give us the original part here, okay? So the thing is, okay, how about we change a sign here? How about we change a sign here and make it what? Plus and minus, such that it becomes plus and minus. So if that's the case, can you see that this is going to change the value here? It's going to be negative 4 plus 1, which is minus 1. And then this is going to be what? Negative 4 plus 4 in this case. Okay? So how do I know here is going to be minus? If it is x squared plus 4x plus 4, then it's going to be plus everywhere. But the minute I have minus somewhere, it tells me that it's going to have the what? The minus. Then can you see now, if I simplify this, it's going to be square the first term, x squared. This time, that is negative 4x squared. The last term, it is plus 4. And remember, this is 1 minus 1. Then can you see this is the same as that? Then it means it is fine. Therefore, can you see I have written this in the standard form? Okay, I can therefore say, therefore, my turning point, it is, remember, if this is negative here, it's going to be positive and then negative 1. Okay, you need to know how to complete a what? A square. Very, very important. You did this in term 1. The easier way that you're going to learn, it is y is equal to negative b divided by 2a, where remember you have y is equal to ax squared plus bx plus c. When you look at this equation here, what is the value of b? The value of b, it is negative 4 here. Can you see? The b goes with x, so it is negative 4. So I'm going to say negative into negative 4 divided by 2. What is a? What is a? A, it is what? It is 1. Then I'm having y as how much? As 2. Okay, sorry, x, not y, x. Okay, then how do I get y? To get y, I'm going to say y is equal to, I'm going to substitute x as 2 on this equation. Then it's going to be 2 squared minus 4 into 2 plus 3. And then when you punch that on the calculator, it will give you something like 1. 4 minus 8, it is negative 4 plus this negative 1. So can you see that I have x is 2, y is negative 1, which is the same as 2 and negative 1. But let's look at another example of completing a square before we move on to another question. Okay, Let's have another example of completing a square so that you understand this part. Let's say we are given a okay. Let's say we are given this and you need to complete the square. So you're going to say y is equal to x squared plus 6x plus your coefficient of x divided by 2, which is how much? Which is 6 divided by 2. I need to square that minus what? The very same number, 6 divided by 2. I need to square that plus 9. But I'm interested in these three first. So I'm going to say this is the same as y is equal to x squared plus 6x plus 3 squared minus 3 squared plus 9. The reason I'm doing this, I want you to see which one will be inside the bracket, which is 3 in this case. So I can rewrite this and say this is x squared plus 6x plus, what is 3 squared? 3 squared is 9 minus negative 9 plus this is 0, like that, basically. Then I'm going to have what? Y it is equal to, can I simplify this? Yes, how? It's going to be x plus, remember I said if it is plus, it's going to be plus. Then what is that value here? The value that you simplified to, it is the one that is going to come here. 3, and then you square that, then you are done. The coordinate of the turning point, it means therefore the turning point, it is how much? Negative 3. What is y? Y is 0. Can you see that? Yes. So yeah, let's move on. What is turning point formula? Okay, so there is, however, a shortcut to determine the turning point directly. When given the function y is equal to ax squared plus bx plus c, the following formula can be used to calculate the x value of the turning point. Very important. The x value of the turning point can be denoted by x, it is equal to negative b divided by 2a. For the y-intercept, simply substitute x into the original formula. Okay? Let's have the very same example, this one. We did that on example 8. Let's do that. But now we know that we have a new formula that that says x, it is equal to negative b divided by 2a. So now what is negative b? Remember, if I were to collect a, it is what? 1. B, it is what? Negative 4, not just 4. C, it is what? It is 3. So what is negative b? Let me use it, substitute here. X is equal to negative, what is b? B, it is negative 4 divided by 2. What is a? 2, it is 1. A, I mean, it is 1. Then x, it is equal to, when you simplify this, you get what? 2. Then if your x, it is equal to 2, like that, then you need to determine your y. Your y is going to be substituting this on the original equation. So it's going to be 2 squared minus 4 into 2 plus 3. And then punch your calculator, will get something like y is equal to negative 1. Then these are the coordinates of your what? Of your turning point. Therefore, your turning point is the same as 2 and negative 1. Can you see 2 and negative 1? Yes. So that is that. Let's have another example again. Okay. Oh, in this case, we are sketching. Okay. Let's sketch then. Remember, what do you need for sketching? X-intercept, y-intercept, turning point. Okay, yes. So I'm going to need, for x-intercept, I'm going to do what? I'm going to let what? Let y equal to 0. Then I'm going to say 0, it is equal to 3x squared plus 6x minus 9. This is good because, okay, then I'm going to divide this everything by 3. X squared plus 2x minus 3. And then, can I simplify this? Absolutely. X plus 3, x minus 1. You have already done this. Like, you know how to simplify this. If you still do not know how to factorize, I won't judge you. Just use a quadratic formula. Okay? X is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay? It's still correct. You will get full marks because, yeah. And then this is the same. If you are to check this example, you have already Okay, no, I'm lying. I'm lying. X is equal to -3 or x is equal to 1. But therefore, it tells me that if x is equal to -3, y is 0, or when x is 1, y is equal to 0. These are the most fundamental points that I was looking for, actually. Then for y-intercept, you let x equal to 0. So on this one, it is where now we say, okay, this last term, y is equal to ax squared plus bx plus c. C, it is now our what? Our y-intercept. I go. C, it is our y-intercept. Why? Because if I substitute x here as 0, x here as 0, this will be 0 and this will be 0. I'm left with that one. But let's prove it. It's fine because people do not believe me. So it's going to be what? Y, it is equal to 3, 0 squared plus 6, 0 squared, 0 minus 9. Okay? So then how much do I get? Y is equal to 9. Can you see that? Then it tells me that if x was 0, y was 9. This is my what? My y-intercept. And then how do I find my turning point? Remember, x coordinate of the turning point, it is equal to negative b divided by 2a. Then what is negative b? Negative. What is b? B, it is 6. I get 6 divided by 2 into what is a? A, it is 3. I get positive 3. 3, and then I get the x value as -1. And then how do I get the y value? I'm going to say 3 into -1 squared plus 6 into -1 minus 9. And then I get something like 3 minus 6, it is -3, -12. Then it means in the coordinates of my turning point, it is something like when x is -1, my y is -12, with the hope that I did not do any mistake on calculating here. And then we are in a position of sketching, right? Yes. How do I sketch? I say, oh, another thing, the value of a here is greater than 0. Then it means I'm expecting a happy face. Then let's try to sketch that. Let's see the highest value. The highest value on the graph is -12. Is it -12? Something does not make sense. So here it is negative. It is negative. Yeah, negative. So it means my graph will be something more or less like this. I want to draw it nicely so that we are okay. Okay, this is my y, this is my x, and my y. Then the first coordinates that I have it is -3 and 0. I might put -3 here, and 1 and 0, I might put it here, and then 0 and -9. And then here I have what? Okay. Oh, so -1 and -12. -1 might be somewhere here, and then -12 down there somewhere here. And then I'm having these. Can you see now, me knowing the shape? How is my shape? My shape is supposed to be like this. The value of a is positive. So I might just take my thing and join. Okay. I have tried. Okay. Then you need to show us the coordinates of the turning point here are how much. I get. Remember, it is -1 and -12. You just need to show us. Okay. And remember, this is just the axis of symmetry. Okay. This is also how you find the axis of symmetry. Okay. This is also finding the axis of symmetry. Remember, the axis of symmetry is the same as the x coordinate of the turning point. Okay. Now let's find an equation in this format, okay? In this format, not in the turning point formula. Now, we have other ways to do that. So, which are these? Because in here, if you realize we are having what? We've been finding what? X-intercept, this one and this one. So in case you are given X-intercept and any point, or you are not given any turning point, then we need to know how to simplify that into a certain equation. So a final form of quadratic equation, which is very useful, it is, let me zoom that out, y it is equal to a into x minus x1, x minus x2. So this is simply the factorized form and blah, blah, blah. In this equation, x1 and x2 are the two x-intercepts, okay? x1 and x2 are the two x-intercepts. The negative sign in the brackets indicate the sign change, okay? This form is especially blah, 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 blah. Let's have an example. Can you see they wanted this answer in which format? Y is equal to ax squared plus bx plus c. If they wanted it in y is equal to a into x minus p plus q, remember what I need is just the turning point and any point. Again, but in this case, they want it in which format? In which format? This one. And when I check here, I have x-intercept and what in any point. If I have x-intercepts and any point, I'm going to find it by using a into x minus x1 and x minus x2. But if I have the turning point and any point, then I'm going to use this one. Y is equal to a into x plus p squared plus q. In this case, I'm giving the x-intercept as well as the any point. So I'm going to say y it is equal to a into x minus x1. There are no squared here, x minus x2. Let's substitute x1 and x2. Let's say this is x1, let's say this is x2. And then this is just any point that has a coordinate of 0 and -6. When x is 0, blah. This is just to x and y. Okay? Then y is equal to a. What is x? X, just leave it as it is for now. What is x1? x1, it is -1. So it's going to be negative into -1 will be plus 1. Okay, I'm not sure if people need to see that. Negative of the side of this one, then into -1, like that. So it's going to form as what? X plus 1. Then I have x minus, here the value of x2, it is just 3. Okay, then I need to substitute any point. Sub any point. Any point, it is what? 0 and -6. So my y, it is -6. A into what is x? X is 0 plus 1. 0 minus 3. And then when I simplify this, I get that -6, it is equal to 1 multiplied by -3, it is -3a. And then a, it is equal to what? 2. If a, it is equal to 2 like that, therefore, the equation, it is, you don't want it in terms of y, okay? Therefore, it is y is equal to 2 into x minus, the first one was x plus 1 again. You need to always come back here after finding the value of a. You come back here, x plus 1 into x minus 3. And then, is it simplified? No. Therefore, you need to simplify this. Y is equal to 2. Factorize or simplify these brackets first. It's going to be x multiplied by x, it is x squared minus 3x plus x, which is minus 2x minus 3. And then, therefore, y is equal to 2x squared minus 4x minus 6. And when you check, the value of a is greater than 0. My face is supposed to be like this. Is it like that? Yes, it is happy. Then I'm done. This is the final equation that they wanted. Then let's look at the other example I have. Okay, unfortunately, we do not have it. Okay, yeah, it's fine. Now, here is a summary of how to find this, okay? So, if a turning point and another point is given, we are going to be using this word, this one. Because now this one tells me about the turning point formula, okay? So I can just substitute this one and that one in any point, okay? Or if I have two x-intercepts and any other point, I'm going to be using which one? This one. Okay, yes. So, yeah, I think, should I end it here or maybe I should look at application? Maybe application needs a new video on it, okay? Okay, let's have a video where we'll be now looking at the application of parabola, as well as we want where the values of x is greater than 0, where the values of x is less than 0. So f of x is greater than g of x is greater than what? All those thing is that most students like to complain with, okay? So yeah, and it's fine. I'll try to simplify that. Please join me on the next video if you really are that one student who is struggling with those type of questions in the last questions, okay? Thank you very much.